Hi, welcome to my video on factoring the trinomial x squared plus bx plus c. This is part 3. In this section I have some extra questions and I have talking about the descending order of the polynomial. Some extra questions that pertain to the factoring is, number 1, explain why each trinomial cannot be factored over the set of integers. So here's the trinomial x squared plus 6x plus 4. And we know, or should know, that the sum is 6 and the product is 4. So this last number here is the product and this middle number is the sum. If you were to write this as two binomials multiplied, notice that the product is positive, so that means we have two pluses or two minuses. Since the sum is positive, we must have two positives if we're going to factor this trinomial as the product of two binomials. So if the product is 4, the factors are 1 times 4 and 2 times 2. Now we're going to factor these over the set of integers, which means the integers are 1, 2, let me write them down, 1, 2, 3, dot, 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 0, and their opposites, negative 1, negative 2, negative 3, dot, dot, dot. So that's the set of integers. So if we put a 1 and a 4 here, we would get a product of 4. We put a 2 and a 2, we get a product of 4. But none of these factors, 1 plus 4 will give me 5, 2 plus 2 will give me a 4. So since the two signs are positive, the factors have to add up. So none of the factors of 4 pairs, the factor pairs of 1 and 4 and 2 and 2 will add up to give me 6. So note, this cannot be factored over the set of integers. B, we have a sum is 7 and the product is negative 10. Again, the middle term of the trinomial is the sum and the end one is the product. And since we have a product, the factors of 10 are 1 and 10 and 2 and 5. Remember, we're talking about the set of integers. And that means that if the product is negative 10, we must have a plus and a minus as the two signs that will go in here. Because when you multiply those two signs, plus and minus, you will get a negative. Now, that means that the factors of 10 are going to differ. Because we have different signs, they're going to differ. So if you take 1 and 10, if they differ, we're going to get a 9 or negative 9. So if you subtract 10, subtract 1 is 9, 1 subtract 10 is negative 9. And if we got a 2 and a 5, and you subtract them, you get a 3 or a negative 3. And notice, neither one of these pairs will give me a 7. So it's not factorable over the integers. Number 2, list all the possible values of k in each if the trinomial is to be factored over the set of integers. Again, the key word here is over the set of integers. So we have a sum, which is the k, and we have a product, which is 6. So if the product is 6, that means the factors are 1 times 6 and 2 times 3, possibility. And since we have a plus, that means if we have a plus, then it's possible that we could have 2 pluses, or it's possible that we could have 2 minuses. So we don't know what k is. So k could be positive or k could be negative. So since the two signs could be a plus or could be a minus, that means we have to look at the factors of 6 and add them up. That will give me a 7. Or we look at the factors of 6, could have been a negative 1, add on negative 7, or negative 1 add on negative 6, sorry, to give me a negative 7. Or we could have a 2 plus a 3, which is a 5. Or we could have negative 2 add on negative 3, which is negative 5. Again, repeat, the product is a positive 6. So the signs are 2 pluses or 2 minuses, depending on what this middle term is. Since we don't know what it is, we have to go with either or. So that means the possibilities for K is plus 7 or minus 7, or plus 6 minus 6, plus 5 minus 5, sorry. So notice the plus minus. This means plus or minus 7, plus or minus 5. So those are the possible values of K that will work here. Again, it's a positive product giving you 2 pluses or 2 minus possibilities. And so we add up the 6 and the 1. We could have positive 6, negative, positive 1, positive 6, or negative 1, negative 6. Or we could have 2 and 3, or negative 2 and 3. Now, number B, we have a trinomial. Again, the sum is the K, and the product is negative 12. So if the product is negative 12, that means we have a 1 and a 12. We could have a 2 and a 6, or we could have a 3 and a 4. So let's look further at the signs. If this product is negative 12, that means the signs have to be a plus and a minus, because the product of those two, plus and minus, is got to be a negative. So that means the factors differ. So if we take a 1 and a 12 and subtract them, we'll get 11. Or we could get a negative 11. I think 12 minus 1 is 11. 1 minus 12 is negative 11. If we got 2 and 6 and we subtract them, we could get a 4. Or we could get negative 4. 6 subtract 2 is 4. 2 subtract 6 is negative 4. And we got 3 and 4. If we subtract them, we get a 1. If we reverse it, we get a negative 1. So that means the possible values of K in this question is plus or minus 11, plus or minus 4, or plus or minus 1. And just to check that, just to show you that, let's pretend that we're going to take the plus 11. Let's show you. So let's see, we're going to factor these two. If we have an x squared, then we have an x and an x. Since the product is negative, that means the signs are plus and minus. Now, the factors of 12 are 1 and 12, 2 and 6, 3 and 4. But notice the factors, since the signs are different, the factors have to differ. So, which pair of factors here differ by 11? 3 and 4? No. 2 and 6? No. 1 and 12 differ by 11. So, that means we can put the 12 positive, 1 negative, or 1 positive and a 12 negative. But because there's a positive 11 right there, that means the bigger number has to be positive. So there's a positive 12 and a negative 1. And just to check, outside is x squared. First is x squared. Outside is negative 1x. Inside is plus 12x. And the last is minus 12. So that's x squared plus 11x minus 12. So that just goes to show you the possibilities. I'm just working extra practice here and explaining how we're come up with these numbers. So again, to repeat, very important to know that if that's the product right there, then that's plus. So we could have 2 pluses or 2 minuses that will fit in the middle. And since that product is negative 12, the signs has to be a plus and a minus. So that means the factors in this set differ. The factors in this set add up. Just reviewing. It's good to review, good to make sure you know what you're doing. And the next page has write each as a bx squared plus cx, write in descending order. Write each as, that should be an S there. Write each as. x squared plus bx plus c in descending order. So some examples. Put in descending order. Descending order, we have a 2, a 1, and a constant. And just to remind you, the constant is understood to be 3x to the 0. And x to the 0 is a 1. So that's why a constant of 3 is on the right side all the time, because it has x to the 0. And that's a 2, a 1, and a 0. So we start with x squared, then we go to 2x, and then we go to 3. 2, 1, 0. I say there's none there, so that's why that's a 0. Just B, descending order. And it has to be an x squared, then it has to be an x, then it has to be a constant. X squared, 1, and a 0. Constant is always on the right side. Number 7, we have a constant, x to the 1, and the square. So it's x squared minus 3x plus a 7. That's a plus in front of there. Note. And notice when we change the order here, we do not change the sign. It's only when we're solving equations. When we move it across the equal sign by transposition, we change the sign. But we do not change the sign when we're rearranging here. Write each as x squared plus bx plus c. Now, practice means you pause the video and work these out. See what you're going to make out. So we got an x squared, we got a plus 7x, and a minus 8. Descending order. X squared is first, then the x, and then the constant. X squared is first, then the x, and then the constant. Notice descending order. We have from highest power to the lowest. So we have x squared is first, then the negative 6x, and then the minus 7. Again, the signs do not change when we're moving these around. So, practice. Write in descending order and factor. So what we have to do now is write all of these in descending order and factor. Because if we don't put them in descending order, we're not going to obey the pattern that we learned. So we have to go x squared plus 2x minus 3. And since it's in descending order, now I have a trinomial, and a trinomial is 2 brackets. To get x squared, we have x and x. And we have a product is negative 3, and we have a sum of 2. That's the way I do it. Since the product is negative 3, that means I'm going to guarantee to have a plus and a minus, because you multiply these two signs, you're going to get a negative. Now, the factors of 3 are 1 and 3. That's the only factors of 3. So 3 and 1 has to go in here. So, because that's plus 2, that means the larger factor is going to be positive. So it's a positive 3, negative 1. Again, that's the sum, plus 2. That's the product. And it's the product that determines what numbers we're going to use. And we're factoring over the set of integers. Number 2, descending order. X squared plus 7x plus 10. Over on the side, the product is 10. And the sum is 7. So we keep that in mind. Factors of 10 are 1 times 10 and 5 times 2. So let's go. Since we have a trinomial, the first terms of the binomials are x and x. X times x is x squared. Since it ends in a plus, since the product is positive, we're going to have 2 pluses or 2 minuses. And the 2 we're going to have is the 2. It's the 2 with the sign of the middle. So since the middle is a plus, we'll have 2 pluses. Again, the product is positive, so you have 2 pluses or 2 minuses. And what 2 are you going to pick? It's the 2 of the middle sign. Because the sum is positive, it has to be 2 pluses. Now, because they're pluses, that means the factors are going to add up. So, factors of 10 to give you a 7. 1 and 10 adds to give me 11. So 5 and 2 must fit. And it makes no difference where you put the 2 and the 5, because they're both pluses. Number 3, descending order is x squared minus 4x minus 21. 2, 1, and a constant. Now we have a product is negative 21. Sum is negative 4. Remember, product is the last term. Sum is the middle term. And the factors of 21 are 1 and 21, 3 and 7. Good, got all that figured out. Here we go. Since we're factoring a trinomial, we use a double set of brackets. To get x squared, we put x and x. And since the product is a negative 21, we guarantee to have a plus and a minus. That means the factors differ. Because they're different signs, the factors differ. So the factors of 21 have to differ by 4. 21 and 1 differ by 20. Not right. So it's a 3 and a 4. So where does the 3 go and where does the, 3 and a 7. Where does the 3 go and where does the 7 go? So since the middle sum, since the middle term is a negative 4 and that's the sum, that means the larger factor has to be negative. So 7 and 3, 7 is negative, 3 is positive. And again, check, multiply these two, negative 21. Add these two, negative 4. Perfect. So we have it factored. And number 4, descending order is x squared minus 11x plus 18. 2, a 1, and this is constant on the end, 0. And we have a product. I always write down the product first, which is 18. Then I do my sum after, which is a negative 11. Because it's the numbers that we multiply together to give 18 will add to give you a negative 11. So that's why I do product first and then sum. The factors of 18 are 1 and 18. It's even, so it's 2 and 9. 9 has a 3, so 18 divided by 3 is going to be 6. So 9 has a 3, and 9 is a factor of 18. That means 18 has a 3. So we have all the factor pairs. So now here we go. X and x gives you x squared. The product is plus 18. So that means the two numbers are going to be 2 pluses or 2 minuses. Since the middle term is a minus, that means I have 2 minuses. Why? Multiply. Positive 18. Add. Negative. Perfect. Now, that means since the signs are the same, the factors are going to add. The factors of 18 are going to add up to give me 11. I already have the signs in, so I don't have to worry about adding to get a plus or a minus. So factors of 18 to add, that's a 19. They're no good. 2 and 9 add to give you 11. Oh, so I have them. And 2 and 9 makes no difference where you put them because they're both negative. So you could have x minus 9 and an x minus 2. It makes no difference if it's 2 and 9, 9 and 2 because they're both negatives. When you add 3 and 6, you get a 9. So I need 11. So anyway, that's a few different style questions. And when we factor, we have to make sure that it's in descending order, in x squared, x, and a constant. That ends this video. If you like my video, then you can click the like button and the subscribe button, subscribe to my channel, and the notification bell because there's more videos coming. And you can write a comment if you're a subscriber. Write a comment on my video. And visit my math website at mathfullyexplained.com and have 3 sections. One is on me, my degrees and teaching experience. The video section tells you about the teaching strategies you're going to use to help you learn the math. And the content section has the topics and the number of videos on each topic. And what's in black font is online right now on my YouTube channel. And what's in red font will be done in the near future. Thank you very much. Bye-bye.